Dasgupta from the Indian Statistical Institute, who will deliver a talk on genetic significance of Glucony from the Protozoic Basins of India. Today, we are honored to have with us Professor Arijit Rai, Head of the Department of Geology, Presidency University. We also have with us Professor Shubhi Shorkar from the Department of Geological Sciences, Jadavpur University. Now I would like to hand over the session to Professor Shankar Bose, Department of Geology, Presidency University.
A very good afternoon. At the outset, I will just request Professor Dasgupta, Professor Arijit Rai, and Professor Shubhi Shorkar to come onto the dais and have a seat. I will request Professor Arijit Rai to offer a flower bouquet to Professor Somnath Dasgupta. Flower bouquet. Angona will deliver this flower bouquet to Professor S. Rai. Arijit Rai. Thank you. Good afternoon again. I welcome you all in this August gathering, which certainly is not a happy occasion because we are gathering here for the Sarbani Patranabis Endowment lecture in memory of one of our alumnus, Dr. Sarbani Patranabis Dev, who was a student of Presidency College, erstwhile. Because of her untimely death in 2022, our family members requested West Bengal Academy of Science and Technology to organize a lecture in memory of her scientific contribution. And this has been organized from the last year. This is the second lecture. So before I offer my thanks, I would like to introduce Professor Sarbani Patranabis Dev. She passed Masters from Presidency College in 1992, and she joined Indian Statistical Institute as a JRF and received PhD from, I would request the change this icon. Yeah. Thank you. And she received PhD degree from Jadavpur University in the year 2000. She did postdoctoral research at Indiana University as a Boycast Fellow. And after that, she joined the same ISI as an assistant professor of geology and attained the level of professor and head of the Department of the Geological Studies Unit. She has specialized in sedimentology and stratigraphy and an excellent field geologist. She worked extensively on the evolution of Protozoic basins of India and published significant papers in many leading earth science journals. She received several awards and honors, including the National Geoscience Award and Slater Fellowship of Durham University. She was elected as the Fellow of the West Bengal Academy of Science and Technology in 2021. She also served as a member of editorial boards of Geological Magazine and Geological Journal and participated as distinguished member in many international field workshops. The Department of Geology, Presidency University, and West Bengal Academy of Science and Technology will remember her as a fiercely competitive geoscientist and an extremely compassionate colleague. I would now request Professor Shubhi Shorkar to introduce the activities of West Bengal Academy of Science and Technology. Professor Shorkar, please.
Thank you, Professor Shankar Bose. At the outset, I'd like to welcome Professor Somnath Dasgupta for this lecture, endowment lecture for Sarbani. I welcome Professor Somnath Dasgupta. So before he starts his lecture, I will talk few words regarding the WAST. WAST basically West Bengal Academy of Science and Technology, founded in 1989 in Kolkata, comprises distinguished scientists and technologists from academia, industry, and R&D organization of West Bengal. So, the guiding objective of the WAST are to promote understanding of basic and applied sciences and technologies, to promote cooperation and excellence through science and technology seminars, conference, workshop, symposia, popular lecture, etc., and through scientific and technological publication, as well as coordinate activity of various agencies and institutions, government as well as non-government governmental engaged in research and development. So before finishing my small talk, I like to mention that this is not a very happy situation for me to attend this lecture, because Sarbani was very close to me, though we don't work together. But I can recapitulate the last project she submitted. I was one of the reviewer. I reviewed the proposal. So it is very pathetic to me to introduce say something about Sarbani. Sarbani was close to the heart of most of the sedimentologists. She was so she can mix us very well. That is the different story, but really it is not a good situation for me to say something about her. However, I like to invite Somnath, and I just convey my thanks for he agreed to deliver this lecture. Okay, thank you.
Before so I will just very briefly introduce his biography. It's not very easy because he has many things about him to say, but just a brief that Professor Somnath Dasgupta is currently the INSA senior scientist at the Geological Studies Unit, Indian Statistical Institute. He got his PhD in geological sciences from Jadavpur University in 1979, long back. He is formerly a professor of Jadavpur University because we are here for him. He was also a founder professor of the Department of Earth Sciences at INSA, Kolkata, Vice Chancellor of Assam University, and fourth Foundation Chair Professor at Jamia Millia Islamia. His academic life is extended for over 3 decades, during which he has supervised about 30 doctoral students and several hundreds of master's students for PhD and master's thesis. He has published more than 120 research papers with more than 6,000 citations. Professor Dasgupta is a fellow of all the 3 national academies in India and World Academy of Sciences, Trieste. Was president of Academy of Science and Technology, just immediate past president. He received many awards, to name a few: National Mineral Awards from the Ministry of Mines, Krishnan Medal and Harinarayan Lifetime Award from the Indian Geophysical Union, and J.C. Bose National Fellowship from DST. He is a guest professor at Ruhr University, Bochum, and visiting professor at the University of Arizona and Hokkaido University. He was international co-leader of UNESCO IGCP Project 318 on polymetallic nodules. He is currently editor-in-chief of the Journal of Earth System Sciences. And beside that, he is an excellent teacher. Over to Professor Dasgupta.
Yeah. Well, thank you, Shankar, and I'm really overwhelmed by the invitation from WAST and Presidency University to deliver this talk on it's a very sad occasion for me because I have known Sarbani from 1995, I remember, at Jadavpur University when she was doing her PhD. And even today, I very badly miss her at the Indian Statistical Institute. I accepted the invitation to deliver this lecture. In spite of that, just thought that this gives me an opportunity to pay tribute to her. And after the flyer was published, I faced numerous queries regarding the title of the topic. Simply symptomologist and not a low temperature geochemist. So how is that I'm going to talk on a topic which involves sedimentology as well as low temperature geochemistry and low temperature minerals. This is not my specialization, but I decided to deliver this talk keeping in mind that this is close to what Sarbani did, and I should talk something related to hard research because I'm talking in hard memory. So that is the driving force of this decision. And also, I just poked into this subject a little bit. So that is why I am in a position to deliver this talk. But certainly you should not expect a talk from a sedimentological top level talk because I'm not a sedimentologist nor a low temperature geochemist. Nevertheless, welcome to this talk. So that's the that is the title of the talk, the genetic on Protozoic Basins of India. I understand the term Glucony is not very popular in geological literature because I faced queries that what is Glucony? So naturally, I will include 5 to 6 slides to introduce Glucony to you in case you are not familiar to that. So what is Glucony? Basically, this involves a family of minerals which consists of glauconitic mica, ferric elite, and iron aluminium smectite. These three combine into a family name called Glucony. And glauconite mica is actually an iron and potassium rich elite, 10 angstrom elite, logically defined glauconitic mica. I study glauconite because it is supposed to be an indicator of the environment of deposition and diagenesis. And secondly, there are certain other issues like an environmental science. Glauconite is used as a mineral for removal of heavy metals from wastewater, and also in fertilizer, that is in agricultural science, the potassium fertilizer. I guess that you know already, the name muscovite is very familiar to everybody, light and glauconite. Basically, what happens is that the iron content increases in this, tetrahedral aluminum content decreases basically in this direction. And these are the polytypes of the different species in this group. Muscovite. So these are essentially micas, so to say. And this classification is based on the work of these two authors. Next, please. I introduced Glucony a little bit. So this is the age distribution of Glucony all over the globe. And I'll be talking about Precambrian Glucony. So it is only 7% of the total Glucony available in the world. It's a very minor occurrence, so to say, but it's very important in my opinion. Next, please. Now, the nature of substrates on which Glucony forms. Again, I will be talking about the substrate of potash sulfur and quartz. So again, a very minor 10% or so of the Glucony formed on potash sulfur and quartz. Most of the Glucony formed on fecal pellets or biogenic clasts. So because most of the Glucony are present in the Phanerozoic time, more commonly in the Cenozoic. So naturally, biological activities play major role. Next, please. And this is the depositional environment of the ancient and modern recent Glucony. Please look at C, D, E, F. This constitute about 80% of the Glucony depositional environment. And the C, D, E, F are basically tidal flat, intertidal zone, subtidal zone, and deep subtidal zones. So basically a shallow to medium depth depositional environment for Glucony. And then next, please. The species-wise, the deposition significance attached to glauconite and ferriculite are like this. Ferriculite forms in lacustrine, lagunal, and fluvial environment. Glauconitic mica forms as a result of marine diagenesis, mostly shallow but deeper water in recent times. Low sedimentation rate, not much terrigenous sediments coming, and then there is no climate control today. Why? Because recently, today, Glucony is found from different latitudes, right from the near the Arctic Circle to the Antarctic. So through the entire latitudes, you get Glucony. So there is no climate control. That is very clear. Slightly alkaline environment, pH around 7 or 8. And weakly reducing and oxidizing condition. Now, why weakly reducing and oxidizing? Because glauconite contains, or Glucony contains both ferrous iron and ferric iron. So naturally, the condition should be very weakly either oxidizing or reducing, or nearly neutral. And also we have the pH about 7 to 8. That is weakly alkaline. Now, these chemical data were available for 75 years from now from the paper of Krugman and Garris in 1950s. What we have read in Garris and Christ's geochemistry textbook, these data was available. And even if I use modern and thermochemical data, I don't get much deviation. So this stands about chemical conditions. Now, these were already known before we started working. But I would like to add a bit in course of this talk. Next, please. So this is the compositional limits of the Glucony family. Now, this is the field of elite, ferriculite, and this is the field of glauconite. This is the field of aluminium smectite. These are mixed layer minerals. Now, there are two ways. The y-axis is K2O and x-axis is K2O3. So there are two ways you can reach to the glauconite field. It's coming? No.
There, but
Very faint. Yeah. So two ways you can come to the glauconite field. One, this side from elite, and another is from aluminium smectite by increasing both. These are the two models that were available when we started working with And next, please. And these are certain nomenclature. Quickly, this is the X-ray chart, and the basal spacing between the basal plane and the 020 plane. People have K2O content 9764 as highly. So this means that the glauconite composition changes as the diagenesis progresses. Right from K2O content is increasing in this direction. So that is what people used to think. Next, please. And this is another model. I showed two models. One was increasing K2O this direction, and another is increasing this direction. Both K2O and Fe2O3 increasing, following this arrow. And this is the idea from Oda and Matter in 1981, widely cited paper on Glucony. This is the most popular paper on Glucony. And both the models imply composition of Glucony evolves presumably with diagenesis. So K2O increases and Fe2O3 increases. Either you start from smectite or you start from elite, you get to glauconite. So that is the idea. So both the models in Sarbani also contributed. That was the background information just to make you familiar with Glucony, because I understand that many people are not familiar. And so this is the Protozoic Purana basins that in India, taken from the publication of Patranabis, Dev and Shah. And you have these yellow ones at the Protozoic basins. So Chhattisgarh is here, PG Valley, Pranita Godavari Valley is here. I will be talking on these two valleys, these two Protozoic basins where we worked, and where also, but Sarbani, of course, worked in other Protozoic basins, but I have very little idea about the others. So I will concentrate on Chhattisgarh and PG Valley. And I'm going back to a bigger, larger scale. So the Protozoic basins are part of the supercontinent cycle. We have these supercontinents in the history, although the names vary from publication to publication. But basically, we'll be talking about Colombia and Rodinia here. The Protozoic basins, most of these Protozoic basins, they formed during the breakup of Colombia, and they closed during the closure of the Rodinia, the supercontinent formed. So in between this 2 GA to 1 GA, most of the Protozoic basins had their geological history. Other than that, there's one basin, that is the Marwar basin, which is a little bit younger. So this shows the span of the Protozoic basins in the time scale. So here is Chhattisgarh basin, and here is Pranita Godavari Valley basin. So these two are almost of the same age in this scale. They formed during the breakup of Colombia, and they closed during the formation of Rodinia. That's the story that we have. And so far, there is not much contradiction on these issues. Next, please. So this brings us finally, what is so special about Protozoic Glucony? What is so special? Why did we work? Why did people spend time on this? Entirely inorganic in origin. No biologic contributions expected, because in Protozoic life was not very common. I mean, it was there, but so far here we could not find any contributions. It forms on many substrates, but most commonly on potash feldspar and quartz. These two are the common substrates on which Glucony formed. Both iron elite and glauconite are mature because they contain high potassium, K2O, irrespective of Fe content. So the Fe content changes, but not the K2O. And then we have the evidence that these are mostly orthogenic, hardly any detrital Glucony. So these were orthogenic form in situ and evolved during diagenesis. Coexistence of iron elite and glauconite on micro scale in the same thin section, hardly reported previous to our work. This was very, very new finding, that they were occurring together in one thin section. And these criteria, they provide new environmental constraints. So we start with the PG Valley. And this is the map of the geological map of the PG Valley modified after Chaudhary et al. 1994, mainly the coloration. The 94 map was black and white. Here we have the color things. We look at this portion where the Pakal group or supergroup rocks are exposed. And we have two subdivisions of Pakal, Malampalli and Buluk. The subgroups or groups, I think different authors, they write the different stratigraphic status, whatever it may be. And then we have the Sulawai group here, which is here. So we will be looking at this area for our talk. Next, please. And this is from our paper, but the sedimentary environments are from Chaudhary and Howard. This is not my work or our work at all. This is, Chaudhary was of course one co-author, and the Pakal group, we have Buluk subgroup and Malampalli subgroup, and we have Glucony occurrences here. The Sulawai group is fluvial, and we have here ferriculite. Then in the intertidal Ramagundam sandstone, we have both ferriculite and glauconite. And in the subtidal Pandikunda limestone with bands of arkose, we have only glauconite. So you see there is a difference. Glauconite plus ferriculite, and then ferriculite. That interested us. What is causing this variation? We know the environment is different, but how does the environment play in a role in the distribution of Glucony? Next, please. So the major conclusions that we came from the PG value occurrences is that remarkably constant potassium content, high potassium content in ironylite and glauconite. We postulated that is because of high activity of potassium plus in the microenvironment due to dissolution of potash phosphate. Fluvial ironylite shows same potash content as subtidal glauconite. So it shows that high potassium content has got no relation with marine diagenesis, at least in these cases. And then the incipiently formed Glucony and the full pellet of Glucony, they have the same composition. So it looks like that the texture evolved, but not the composition. The composition was fixed right from the beginning. So composition of glauconite is not a function of degree of diagenesis as postulated earlier. Not a very easy thing to push in a paper. It took a lot of revisions, submissions, resubmissions, and finally it got through. It was not a very easy because it drastically alters our idea about glauconite. Then coexistence of ironylite and glauconite in intertidal environment, that was a periodic influx of fresh water. Fluvial ironylite can be distinguished from subtidal or intertidal marine environment ironylite on the basis of magnesium content. Not a very unexpected conclusion. Seawater contains more magnesium, so it's expected. Next, please. Then this particular diagram was a bone of contention. We showed that there is no compositional gap between ironylite, which is on this side, and glauconite. The data points fall in between. Now, this was a bone of contention because everybody showed previous to this that there is a compositional gap. And now, many papers have been published which show that there is no composition gap like this. I don't know exactly the reason, but we found it. And we developed a new genetic model of Glucony by pseudomorphism of potassic feldspar or potassic precursor through dissolution precipitation in a closed system with available magnesium and iron in pore water. Now, this is again a bone of contention. As you can understand, it is not an open sea condition that we are visualizing. We are looking at microenvironment in the pores of the forming Glucony. So lot of trouble pushing that idea here. Then Sarbani reported the first occurrence of iron halide from deep slope marine environment. That is her paper in 1998 in Journal of Geology. Then Chaudhary et al. 1994 showed another drastic change of idea, that is the Glucony form in tidally influenced sediments. So not a low sedimentation rate or low energy environment. So again, a change from the traditional view of low energy environment to a relatively high energy environment. Glucony can form here as well. So these were the main conclusions that we had. Then we look at the second occurrence, that is the Chhattisgarh Basin. This is the map of Chhattisgarh Basin, but we will look only at this yellow one. This is the Deodanga sandstone, which is occurring within the Chandi limestone, this violet colored stuff. So we'll look only at this portion. Next, please. This is the stratigraphic succession, again from Saha and Patranabis there in 2014. And this is the Chandi formation, which is a tidally influenced carbonate platform. And within that, there are layers of sandstone, and those sandstones contain Glucony. So we will look only at these things, not the entire sequence. So please remember that again, we are coming to a tidally influenced carbonate platform. Next, please. This is just a compositional spread, so this is same as the PG Valley occurrence, so I skip this. Now the major results of the Chhattisgarh Basin. In addition to what I already described in the PG Valley, so I'm not going to repeat the same thing. So first is the evidence of orthogenic origin of Glucony at Chhattisgarh. You see, these are all found in thin section scale, replacing at different levels. So this is just the starting, and this is almost full. These are almost full. But the composition is same. The composition does not change with the texture. That's an important paper, an important observation. We observed this also in the PG Valley. I could not show you a diagram simply because the diagram is black and white and will not come out here very well. So I took from Arti's PhD thesis this particular diagram, but it's the same. Next. Then we describe a phenomenon which is very interesting. It's the oxidation of Glucony with the iron oxide. We now stretch our imagination a bit and think of sea level change as a result of this oxidation. I hope the reviewers will accept that. I don't know. But the question is that this is the point that during the first stage, when the Glucony dissolved, led to release of iron, that has to be ferrous iron, so you need an increase in the depth of the basin. So we think that is because of the marine transgression or the sea level rise. And then when the sea level fell, in the next stage, then the oxidation took place and some influx of subaerial exposure, influx of fresh water, anything is possible at this stage. And then the precipitation of iron oxides as trivalent iron took place. So that's one observation that we made, and the conclusion regarding the sea level fluctuation. Next, please. Then, of course, this particular method has got big uncertainty, but you must understand that we are looking at very low temperature processes when Gibbs free energy is overridden by kinetic constraints. We already know that. And so the Gibbs energy of formation is not the sole factor that can drive a reaction. It only tells you that it should happen, but whether it will happen or not is a very difficult question. Nevertheless, we tried to do this to calculate the delta GF, and how did it? This method is by this author. Actually, this is a modification of Bob Garris's method, where he actually used oxides and hydroxide summation. Here, this gentleman has used all hydroxide summation. And we came to this particular model, which shows that ferriculite has more negative delta GF, gives the energy of formation. And then the fourth point is Glucony formed on quartz and potash feldspar. Both have same K2O and Al2O3 content. So we think that this is because of the pore water, which was buffered at high values of dissolved potassium, aluminium, derived from dissolution of potash feldspar. That's the model. Then next is that we try to calculate model balanced chemical reactions. It's a very, very difficult thing. To do that, took an ironing model, we used the software, of course, and calculated this. Now, this gave us two very interesting things. I will not tell you to believe the stoichiometric coefficients very rigorously. It all depends on the composition of glauconite and ferriculite we took. So there is a lot of uncertainty in that. So I will not say anything about the stoichiometric, the value of the stoichiometric coefficient, but look at the product. When potash feldspar dissolves, you have potassium on the right-hand side. So this potassium can go here, and then it can convert quartz to glauconite. So it can be a closed system within the quartz feldspar domain that these reactions can take place. And the second one was very interesting and surprising. I never thought that this would happen. That is, hydrogen is produced on the right-hand side. Now, this is a very interesting observation. We need to pursue this in future, because you know that generation of hydrogen is a top priority today in terms of green energy. And we look at the production of hydrogen through different methods. And marine oxygenesis, if that can produce hydrogen, it will open a new, absolutely new vista of research. So this is something we have to check it. This is not, I'm not saying that we have hit a jackpot here, but the question is, it's an idea. We got some preliminary results. Let's see how it evolves. Next, please. Now, this is the finally that we came into this environmental interpretation of Chhattisgarh. So basically, it is guided by two factors. One, the redox cline. The glauconite formation has to be close to the redox cline because they are Fe2 and Fe3 together. The redox cline was dynamic in the Protozoic, and second, there were iron 2 rich columns of water. Many publications by different authors have shown. So what we want to show here is that this redox cline was dynamic, and that changes from the without Glucony sandstones to Glucony to ferriculite, and then again without Glucony. And all these happened because of the mobility of the redox cline, as well as caused by probably seawater, sea level fall, and sea level rise. So we initially think that after the carbonate deposition, the tidal platform, there was sea level rise. Then what happened is that the heterolithic mud layers deposited, then the sea level fell when the sand dominated plus came in, and at that time we have this Glucony to form at the first level, and then more and more oxidizing, then came the ferriculite. And beyond that, when it became totally oxidizing, then neither glauconite nor ferriculite can be stable, because I said that it has to be close to the redox line. So that is the model that we proposed on the statistical evolution. Next, please. And this is the summary. The summary of what I talked over the half an hour. is that the environmental interpretation of glucony on potassium or iron content cannot be done with potash phosphor as the substrate. It is not the macro environment, but the micro environment that plays role. It's a closed system evolution. And it was extremely contentious, I should say, conclusion, and when it is discussed also widely. Then we proposed this origin of glucony by pseudomorphism of potash phosphor, and towards textural evolution of glucony does not correspond to compositional evolution. So the degree of diagenesis does not control the composition of gluconite. Again, a very contentious problem. Marine origin of ironolite is possible. You may remember the first slide I said lagunal, lacustrine, etc., etc. But it is possible that we have a marine origin of ironolite. Low sedimentation rate is not universally true. It may be true where the other people describe, so naturally this has to be true. But in our cases, no. We are looking at tidally influenced situation. Then the proposal that the redox control of glucony and oxidation of glucony probably directed by sea level fluctuation. So are we looking at a Protozoic sea of cycle of marine transgression and regression? That is something that we need to look at very carefully. It's a very interesting research that can go on for some time. I hope that people will follow. My time has ended, but others may do that. But the final takeaway message from whatever I said is that care must be taken to interpret the positional environment from compositional characteristics of glucony. It's not universally true. I'm not meaning to say, particularly to the young students, that all the other work is wrong. No, they can be right. But what we say here, under the Protozoic situation, where potash phosphor and quartz are the substrates of formation, then the situation is different. And so, in Protozoic, one has to be careful about depositional environment. Now, in the recent times, you don't care because you can see the environment. So you don't need a mineral to identify that what is the environment, because you can go and see. But in the Protozoic, you need to find a mineral or a proxy to interpret the environment. Gluconite is not your proxy. Let's be careful about that. Part of all this work was contributed by Sarbani, and then she did a lot of other things other than this particular gluconite issue. A lot of other things, as others have told, that she was a very eminent sedimentologist and worked on different. But this was a part where I could discuss with her and trying to formulate a proposal which never materialized because of her untimely death. So I do not have a paper with Sarbani. That is one thing. But we worked together for so many years, right from 1995, when she was a student in Jadavpur University. So and all these work took her, next please, to become a fellow of WAST in 2022. And so I remember the occasion when I had the good fortune to hand over the certificate to her in this program. So I remember the occasion very closely, and I wish that I would not have to be asked to give this lecture today. That is very unfortunate situation for me. Now, finally, the last slide is that our study of glucony is a very unique thing, I worked with 3 academic generations on this problem. And this is really a fantastic, unique thing that I am fortunate enough to work with 3 academic. This is Professor Osru Chaudhuri, this is Professor Sukamal Chando, and this is Sarbani, of course. So they are in sequence PhD students. Professor Chaudhuri is a PhD student of Professor Chando, and Sarbani is a PhD student of Osruda. And I had the good fortune to work with all 3 of them. So this is a very unique situation, and I dedicate this presentation to the memory of Sarbani, of course, but I also take this opportunity to pay my tribute to my teacher, Professor Sukamal Chando, who made it possible for me to look at a hard rock petrologist to look at sedimentary rocks. So hats off to the gentleman. And then Osruda, of course, provided all the encouragements, and together, I think Professor Chando, Professor Chaudhuri, and Sarbani at that point of time was just a PhD student, and me, and also Pulak Sengulkar. And so we formed a very nice team together, working in our spare time when we were not looking at metamorphic rocks, working on our spare time on this very interesting problem. So it is very nice for me at least to remember that time. And as I said, I miss all 3 of them, unfortunately. All 3 of them, and in particular, Sarbani's very untimely demise also made me very sad. Nevertheless, thanks for your patience, and thank you very much for attending this lecture. I hope I didn't take a lot of time.
Thank you, Professor Dasgupta, once again for this enlightening lecture. Students who don't know him, he is a very colorful person, and his studies travels from sedimentology to metamorphic rocks. And you can see that how we introduced reaction kinetics, thermodynamics into sedimentology. So it's very nice to see him here. And normally in endowment lecture, we don't expect questions, but if you permit 1 or 2 points may be discussed from the students. Yes. So if you have any queries, feel free to ask him. Yeah, you can also discuss with him personally. He's very friendly, and his life is dedicated to students. So okay, then at this hour,
Any questions?
yeah, if you have 1 or 2 quick questions, please feel free.
Or I was absolutely clear that you don't have any question. That will make me very happy.
So if there is no question, let me offer a vote of thanks for this August gathering. At first, I express my gratitude to the Honorable Vice Chancellor and Registrar, Presidency University, for helping us to organize this lecture here. And I also offer my, acknowledgement to the West Bengal. Yeah.
Just 1 minute, I forgot. It will be criminal on part of me if I do not mention the name of Professor Shantanu Banerjee from IIT Bombay, who helped me in this adventure of Glucony that I have taken up. The later part from 2000, it was because of active encouragement. So I will be doing a great injustice if I do not mention him specifically. Thank you. Sorry.
It's okay. So I will also, offer my acknowledgement to the West Bengal Academy of Science and Technology to give us this opportunity to host this lecture. Head Department of Geology, Professor Urijit Rai, has provided all the infrastructure, and the faculty members of our department and non-teaching staffs, they provide all support to make it a successful. And finally, the research scholars, particularly Shanta, Mogoni, Kaushik, and all who are presented here, they give us all the technical support where actually I failed. So thank you all, and I offer congratulations to all of you for coming here and hearing this talk. And there is some tea and coffee or some snacks are there in the balcony outside. So please help yourself. And thank you very much. And I think I should close this meeting here. Thank you.
Thank you.